So I have started recording now. Okay.
Yes,
So
sir, it's
now
visible.
you now know. So you have a knowledge on how you are going to run the containers. So you know containers, right? So you are going to manage the VMs also. How you are going to manage these VMs? Okay. So today what we are going to do, we are going to bridge that gap between these containers, VMs. Okay. Uh, you can run a container, okay, and you can run even 5,000 container without losing your sleep. Okay. So we are going to see uh, the pattern, conceptual foundation, everything we are going to touch it. Okay. So you will have all these concepts here with the Kubernetes. Okay. So we will be looking at how we are going to cover this. Okay, from containers to orchestration. Okay, we will have 6 sections here. We will spend the most of the time on building the core building blocks. Okay, so how you are going to scale and the ecosystem. So we will be looking at this. Okay, by the end of this session, you will know what a deployment or what a service is, how they are exist and how they connect it. So let's see. We'll do a quick recap here. So you know what is virtual machine and what is containers here. So you are aware of this, right? Full guest OS per instance here. So everything you will be running at full instance here. Like completely you will install it. Then it is heavier to boot or start it also. It will be heavier. Okay. Whereas in container you will be using the host kernel itself. Directly you will be firing up the OS. Okay. So you let me know you are okay with containers and virtual machine. You know the concepts now.
Yes, sir.
Okay. So here Kubernetes is not going to replace anything
Yes, sir.
here, not the container or the VM. So it is going to uh, solve the problem, or it going to manage the managers at scale. If you want to increase, then that is going to scale it. Okay. Now let's say, so containers alone don't scale themselves. Okay. Let me draw it here. One line. Okay. So you are doing a SSH here at let me draw it. Okay. I will take this. So this it is not working. Okay. So you are having one server. SSH is running here. Okay. At 3 a.m. This has gone down. Okay. So now this is the main point here. You want to deploy a app manually here. Okay. to go and deploy one app here. Okay. So it needs to talk to a database and another host. So you have hard coded this IP address in this machine here. Okay. So pane number 1, okay, that you have to deploy one app. Pane number 2, you have hard coded this IP address and it crashes at the midnight at 3 o'clock. This is one server. Okay, you are not able to do. So what Kubernetes will do, it will manage, it will remove all these 3 factors. Okay, like it will be orchestrating it, everything it will be automating and moving it to a different server. Okay. So let's say you are doing everything, you are starting, stopping, replacing container by hand on every host. Okay. Let's say you have a container on one server. Okay. So you have one more on another. Okay. So you have one more on other. Okay. Like that you have. There is no built-in networking here. Okay. These are not connected. Okay. So they cannot easily communicate with the other host here. So you let's say this is on your laptop, this is on a different laptop or a different server. Let's say these are on a different server and this one is on a different server. Okay, this is how they are hosted. Okay, so they don't have a internal connectivity between these hosts here. So that is why there is no scale up or there is no built-in or no self-healing methodology when the server is crashed. Let's say if this is crashed, you cannot retrieve it because there is no tracking mechanism here, because everything is running manually here. Okay. Crashed container stays crashed until a human notices it. Until we notices this will be completely crashed. Okay, you cannot retrieve it. So at 5 containers, this is fine. Let's say you are having 5 containers. Okay, so I will put it one more here. Okay, so I am fine with the 5 containers. That's it. Okay, let's say I am managing 5 containers in one host. Then I can be able to do it. Then that is fine. Okay. At 5,000, you are running 5,000 containers, then you are not able to manage this scale here. So for that, what you will have, you will enter into a orchestration platform. Okay. So where it will be automatically deploying, scaling and operating the all containerized environment here or applications. Okay. So this is a Hammond's man. We call this as Hammond's man. Kubernetes is Hammond's man. This is a Greek terminology. Okay. So now you are not rowing on a boat now. Okay. Individual boat. Let's say individual boat is a container. So you are not doing a individual boat. Now you are steering that fleet. So you have that steering wheel right on the Kubernetes. Now you are enforcing all the abstraction layer and you are using it. Okay. So what Kubernetes will do, if a container dies, let's say you have 3 containers. Let's say you have 3 containers. If one goes down, if one dies, let's say this is going to die. Okay. What Kubernetes will do, it is going to replace it automatically. It will have all the networking, everything. It will just take care of it. Okay, whatever is running, it will take care of it and it will automatically replace it with the into another host. okay, or another node here, okay, it will just switch it over. Okay, so that is the self-healing property of Kubernetes. Then you want to add lot of containers. Okay, I want to add 100 containers. Okay, every Monday I will add sorry, every Monday I want to add 100 containers. Okay, every Thursday I want to remove 80 containers. Okay, on Saturday I want to remove 20 containers. Okay, so this is my day-to-day task. Okay, so based on the demand, Kubernetes will be doing this. Okay, you don't have to interfere. It will add or remove the container based on the demand. Okay, not the human decision. Okay. Then you want to write something what you want. Okay, configuration. I want the configuration like my application. Okay, application should be running on 8 servers. Okay, so it should be running on 8 servers, or else, so my overall capacity should be 70%. Okay, on any given container, if I am utilizing more than 70%, then so I should be running it on a different container. So this is my declarative configuration. Okay, so then Kubernetes will see, okay, I have 70% now utilizing, then I am going to move or create one more container, and then I will place this application. Okay, now I want to run the application. Okay, I want to run a application. So not by IP address. I am not going to figure it out by IP address. I want to run a MySQL server or a Nginx or a application like Apache Tomcat. Okay, so services find each other. Okay, you are having a services here, so I am having a app here, so there is a DB service. Okay, so each services find by each other by name, not by the IP address. So you have IP address here, this IP address, so it will look for a service here. Okay, service discovery. Okay, in Grafana, in Prometheus, you will configure the service here. Like I want to monitor particular service, so you will be capturing that particular service. Okay, so this is why it is useful when you want to, why Kubernetes is helpful here. So let's say you are having this. Yesterday we saw the control plane here. One minute. Bangalore. So yesterday we saw the control plane here, where everything you are making this control here. Okay, so this is where you have ship and crew here, which are making the decision here. Everything this is going on the API, and then it is hitting on the worker nodes. Okay, so you have all the configuration at the etcd, then you have scheduler, and then you are having a control manager. This is on the control side. Let's say you want to control here. Let me see. Okay. So I have 1, 2, and 3. Okay. These are my control nodes. So these are my worker nodes. Let's say this is like a rail bogie. Okay. So these are rail bogies, and these are the railway engines. Okay, which are pulling. You have 3 engines here, and you have 200 worker nodes. So where they are running. Okay. So worker node, it will be carrying all the activities here. So whatever you want to execute, it will be running here. Okay, your containers will be running here. Let's say. So I have dash dash. I will put here dash dash, then dash, and then I will take one more here. So 1, 2, 3, and dash dash dash. The other one will be 200 here. Okay. So I am running it 200 containers here. So I have 3 master nodes like rail engine. Okay. Let's say if 76 has gone down. Okay. The container 76 is having an issue. Okay. This has crashed. So what Kubernetes will do, the master node will know, okay, this 76 has gone down. So scheduler will see, okay, where I can put this 76 workloads, or we will call here as pods here. We will not call workloads. We will call them as pods here. Okay. So now all these will be replaced into a free container wherever it has to go. So we will take this green here. Let's say this identified 184. Okay, this is having free space or free resources. Okay, so this it will go here to 184. This it will be automatically done by the Kubernetes here. Okay, so whatever you are using this, so this control plane will decide where to go. So these are all it will be running now. Okay. So you want to do a auto scaling here. Okay. So you want to use, let's say the demand is only at 70. Only 70 are running now. Okay. Rest of them are 130 are powered off, or they are not in use. So whenever there is a demand, you want to increase it automatically. Okay. So Kubernetes will add it into a auto scaling mode. Okay. I want to get that completely added into that. Okay. So this it will be taking that decision here. Okay. So now you are doing some configuration here. So you will do that configuration as well. Okay. So let's say think of control plane as a management team. This is a management team. Okay. And these worker nodes as a factory floor. So they are all workers. So these 3 are managers. They are telling what to do. Management decides what should happen here. So where workers will be actually doing the work here. Okay. So this is how it will be done. This is your brain here. Okay. These are your muscles. So key concept is here, through IPI server, every command will be, every status update, every recovery action, everything it will be going through this API server. Okay. So now we will see what is the control plane here. So this is the brain. Okay. So where everything will reside here. Okay, if you run kubelet, kubi control, apply, kubectl, apply. So this is command. So you are talking to the API server here. Okay, if you run this command, you will be talking to a API server. If a pod crashes, pod means a small unit, just like a VM. Okay, and it needs a replacement. Let's say this needs a replacement. Okay, the controller talks to the API server. Okay, so the controller will start talking to the API server, and it's the switchboard of the cluster. So your controller, it will be a switchboard to the entire cluster. Okay. And you have etcd here, configuration. This is where everything Kubernetes will remember everything. Okay. So if this disappears, okay, let's say if this is not running, Kubernetes, the cluster forgets what it is doing. Okay, it will act as like a Gajini. I don't know what I have to do. So if I have a configuration, what exactly is happening, then I can do, or I can take the decision. Okay. So in managed offerings, let's say you are having yeah.
Sir, can you repeat when we apply kubelet content?
Sorry.
When we apply
Hello.
kubelet.
Sir, can you repeat when we
Cube
apply
control, sir.
kubelet
We are talking
wanted?
about cube control.
When we apply kubelet, kubectl.
So we are talking about only cube control only. Just
Okay.
these are just basic. We have not yet started installation. Nothing.
Okay.
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 So if you just apply this command, okay,
Yes.
on the API server, you are talking to the API server.
Okay.
Okay.
Oh. Okay.
Okay. If the pod crashes,
Yes.
let's say you want to have a replacement,
Hmm.
then the controller talks to the
Oh.
API server.
Okay.
So from here, it will be talking to the API server. See, this
Okay.
pod has gone down. Okay, this. So you applied this. Okay. So this one will go like this. Okay. Then it
Okay.
will see. Okay, what I have to do? I will check the configuration. Okay, wait. So what is the configuration? I will see.
etcd is the configuration.
Yeah, configuration. Okay. It will remember everything. Okay.
Okay. etcd
And
is the configuration.
whenever you are managing here, EKS or GKS or
Yes.
Okay.
AKS,
Yes.
okay, you will not see this etcd configuration. Okay, this will be completely hidden from
Yes. Yes.
you. Okay.
This, that time it will configure by Amazon or
Yeah,
Azure.
that vendor will take care. You don't worry about
Okay.
it.
This
I will take care,
that
because if I
time
give you, you
it
will
will
enter
configure
this
by
queue of the
Amazon or
entire
Azure.
platform. I don't want you to take care. You tell me, I will do it. Okay, that is what vendor statement is. Okay, it's a like it is a blessing and blind spot, both. If
Okay.
you are managing, then you will see this etcd, or else if it is managed service, you will not see this etcd. Okay.
Yes.
So you have here scheduler here. Scheduler is not just randomly picking up. So it is not randomly picking up the chicken
Understand.
and slaughtering it. Okay. That's not how it works. It will consider the resource request. Okay. So let's say I have one application. Okay. So I have app 1. Okay. So this should be running on 8 servers. Okay. Let's say this should be working on 8, 3, okay, dot, 8. Okay. And all servers, it should not be running on the same physical node. Okay, it should be running on in a different pods. In different containers. Okay, and it should be
Okay.
completely physically separated. Let's say this is having 20% usage. This is having 20%. Okay, and you have it 70% here. Okay, let's say one you have
Okay.
got a free resource. Okay, which is
Okay.
90%, let's say, utilization.
Okay.
By by the, uh, by the algorithm, you should not place it when it is 90%. Okay.
Okay.
So you have configured it. It should be on the separate servers. Let's say you have only 10 servers. Okay. On 8 servers, you have already running. One is crashed and one is having 90%. The other one you cannot put. Then
Okay.
it will be automatically picked up. This scheduler will pick based on the configuration. Okay. So how you have configured, it will pick based on your request. Okay, it will consider your resource request, any affinity rules. So whatever I am talking about, this is a affinity rule. You have affinity and anti-affinity. Anti-affinity means they are like anti-affinity means they are like brothers. So if he is having lunch, then I will not have lunch there. Okay, I need a separate room. Affinity is like sisters. Wherever she goes, I will also come. Okay. So like in one server, all these, let's say all 4 will be running. Let's say these pods you are running. This is on a single server. Okay. This is a affinity. Anti-affinity means, okay, if you are running it here, okay, so the other app, pod will not run on this server. It should run separately. That is anti-affinity. Okay. So this is the VMware concept, not VMware concept. This is the cluster concept. So where you will have a anti-affinity rules. Okay. So you can think of it as a very fast, very project manager assigning tasks or taking the decisions to the desk here. Okay. So now you have a controller manager here. So this is a autocorrect here. So whenever you type something, it will be auto-corrected in your Word document. You have autocorrect, right? When you type something or you do some activities, it will autocorrect. Okay. So this is a autocorrect of Kubernetes control manager. Okay. It will be constantly asking, okay, does reality match whatever is present in the YAML file. So whatever you have configured it in a YAML file, it will see, it will observe, and then it will do. Okay, let's say you have given one configuration, okay, in a YAML file. Okay, so it will check whether we are satisfying this YAML. Does it match? Okay, if it is not matching, then let me fix it. Okay, so this it will go in a loop. Okay, so this is where the heart of the Kubernetes, the control manager, it is called as heart of the Kubernetes. And these are the 4 components that you will be asked in an interview. Okay. So you tell me about the control plane, how it manages. So you at least you should be telling this four components, what each component will be doing it. So now we have a worker node now. So this is where all the work will happen now. Okay, whatever we are doing, everything it will happen here. More colors. Okay, I will take white. So you have a kubelet. Okay, you have a kube proxy, and then you have a container runtime here. Okay. So this is the agent on every node that keep its own assigned parts running and healthy. Okay. This will ensure that whatever parts are assigned here. So I am running 80 parts here, means your 80 instance or 80 VMs. Okay. So this it will be managing that. Okay. It is like a forearm. Nodes forearm, like hand. Okay. It watches the API server for any instructions. Okay, like okay, run this pod. Okay, and then tells the container runtime to make it. Okay, so if the pod isn't healthy, then it will tell, okay, the pod is not running fine here. It will report back. So then the API server will take the decision here. Okay. So this kube proxy, this is where all the networking will happen here. So all the network rules, how it has to connected, where it has to go, everything networking will happen it here. Kube proxy maintains the IP tables. IP tables means your firewall rules. Okay. So how to go, where to get all that back-end parts, everything it is going to manage. Okay. This is like a invisible cop, or invisible, you can say it as a police. Okay, which will be managing all the networking part. So container runtime, okay. So Docker used to be default here. So container runtime is, you will have a Docker, it will be default. Now modern Kubernetes uses container D as a runtime engine. Okay, earlier it was Docker. Now we are using, in modern, we will be using container D or CRIO, okay, where you will be running these images. The runtime is the actual image where you will be running this. Okay. So and the Kubernetes is your driver here. So driver will be driving the vehicle, and this is the actual engine where you will be running this. Okay. This is what happens in a worker node. So when you things goes wrong, okay, let's say when you want to debug something, so you will connect to that particular node. Let's say you are having one node here. Okay. So this is on a Linux server. Okay. Let's say you are running a 200 pods here. Okay. So you will SSH here, SSH to this server, and then you will check on the kubelet command here. Kubelet. Okay. So you will check the kubelet logs that you will be doing with journal control. Journal CTL. So, and you want to see this particular, what exactly is happening. Okay. These are all the three components which are the, where the rubber meets the road here. Like this is tire, this all will be used to run the node, actual node. Okay. Now we have something called as pods here. Okay. These are the core building blocks, the smallest deployment unit. Okay. Just like how we used to do it in virtual machines. Okay. So you will think like this is a container. Pod is like a container. Okay. It's not a container. Okay. Pod is a hosting context. A pod is a hosting context or a one or more containers. If you are running one or more containers, so that is what we call this as a pod here. So that will share a networking and storage, which we will call it as a pod here. So if you are talking about multi-container pods, okay, so usually one container per pod. Okay, you have one pod here. Okay, so one container per pod. Okay, so this is one another pod. This is one more container here. Okay, so they share all the local host and volume. Okay, so this is running on one server, physical server. Okay. So you have pod here, this is one pod and this is one container and this is one another container. Okay. So if they want to talk to each other, okay, then they will be talking to localhost on port 8080. Okay. They cannot talk like this. Okay, we are onto the same machine. Let's speak. So they are not going to talk like this. They will talk to the physical host on port 8080 without any network head. Network overhead means, let's say, so this is your network. Let's say this is your network. So it has to go to the network and then it has to come back. That is called overhead. So it will be directly talking on the physical host itself. Means on the same laptop, it will be talking to like a host only network. Or you can think it in a way like guest network or VM network. So where they will be speaking to each other on the same physical host. Okay. And now disposability. Okay, let's say we'll talk about disposability here. So Kubernetes does not start a crashed container, okay, in a place. Okay, let's say you have crashed a container. Let's say the container is crashed here. Okay, so you have one more, and then you have one more here. Okay. So what it will do? It will spin up a new pod here. Okay, this will create a new pod. Okay, and then it will start running now. Okay. So outside the cluster, let's say this is on the cluster. If this crashes, it will start new pod and then it will manages or it will move all the application or services to that. Okay.
So this is like auto scaling, huh?
Auto scaling is different. This is like a HA.
No, they are auto healing.
So this is like auto scaling, na?
Okay. Yes.
So let's say
No, they are
this
auto
makes
healing.
a system
Okay.
resilient. Okay, but
Okay.
means your app must be stateless by default. Okay, so your app should not know where it is running. Okay, So your app should not know where exactly I am running. That is called as stateless. So it doesn't care where it is running. It should be living in the volumes. Okay. Only it has to be at the storage level. It should be focusing. Okay. I am running from this D drive or E drive or F drive. Okay. So where it is running, it should not care. Let's say it is running from a shared storage. Okay. So let's say we will take the example here. Okay. Let's say in this crash scenario. Okay. So let's say you have one container here. Okay. These are all sidecars, all the containers. Okay. Let's say you have scheduler here. So scheduler will be why can't it directly schedule it? Okay. Why an extra layer here? Okay. So why you want to take all this? Because pods give a Kubernetes a stable unit to monitor, okay, to schedule or replace. Okay. So I am having a small pod. So they are like a atom in the cluster. Okay. So you can monitor me, or you can schedule it, or you can replace me. Okay. So I will be running here multiple containers. Okay. So you don't have to be doing that. Okay. You can replace me, or you can create one more pod and you can assign these tasks here. Okay. Let's say you are running the application, then you can move it and you can run. Okay. So this is how pods will be working. Then you have deployment models here. So deployment models describes the desired state. Example, run 3 replicas. So I want my application to be running in 3 servers. Run these 3 replicas. Okay. So this will be like my deployment. I will be, once I deploy, my app will be running here, instance 1, instance 2 and instance 3. Okay. These are all my replica set. Okay. So you write a deployment, Kubernetes will create a replica set to enforce that replica count. Okay. So this application should be running here in the 3 instances. It should be running in 3 instances. So whenever this goes down, let's say if this container goes down, whatever is inside this pod, that it has to pods, then it has to run it on a different containers, or it should ensure that there are always 3 replica set. Wherever you manage, you move it or you migrate it, this will keep on watching it. Okay, continuously ensure that that many pods exist here. Okay. So that's it for today. Okay. So you have deployment here. So you have replica set. So it will be guaranteeing you. Okay. So I want n replicas guaranteed. In our case, so it is 3. Then it will be running 3 pods running there. Okay. So crash pod, let's say this is crashed here. Once it is crashed, it will automatically replaces in a different pod. Okay. So I am running it here. Okay. You go and run on the application. Okay. On this, the application will come and sits here in this. Okay. let's say if node 1 dies, okay, the other and takes two pods with it, okay, then the deployment will notices via the controller loop, okay. So you have controller here, this controller here, okay. So you have controller here which will be managing here. So it will see, okay, whether the state is replica set is okay or not, okay. If you don't have that many replicas, I am going to place this application or pod into a separate pod, okay. I am going to create it. Okay. So then it will schedule it for a replacement, okay. This is gone down, okay. That will schedule it, okay. You create one more here and you move this, you create one more pod and you run this application, okay. So you want to do some updates here. So you want to do some update on the application. Let's say you have a security loophole. You update the entire image, okay. Let's say on these container, you want to update that image, okay. So once you update it, you apply it. So these containers all are running on a let's say your containers are running in a, let's say, Nginx 1.1, okay. Let's say these two are running, okay. The third one is going to move it, or this is going to replace it, or some other issue like it got crashed or something like that, okay. So you have updated the Nginx version to 1.2, okay. So whenever you create it, it will automatically run with 1.2. So these all will be running in 1.1. So this will be running automatically on the latest image, okay. So you don't have to worry on the deployment model here, okay. So that's it. What we'll do, Thursday we will do some practical, okay. Then we'll see how the Kubernetes will be working in a realistic environment. So we will see the installation and then we will work on the worker nodes, then on the pods, and then on the master node as well, okay. So all I want you to have your Ubuntu VMs ready, okay. So for one last time, you ensure that your Ubuntu VMs are working fine. You ensure that you have at least 2-3 instances, like 3 copies on your physical server, that is on your workstation. So then after that we can do it on the Amazon, okay. So Thursday we will be doing this practical. First we will do it on our local machine, then we will do deploy it on the cloud, okay. So that's it for today.